Alright, in the video, I talked to you about being able to write an exponential equation once you have determined that a table represents an exponential function. And I believe the gist of the video was talking about making sure we were able to identify the parts. And the number inside the parentheses was the multiplier, which we could determine in here. To get from one point to another, you're always multiplying by 6. And a in the exponential equation was the starting point. Well, here we don't have the starting point. We could get it, though, by simply continuing the table downward. But let me go through another method that might be helpful. Here we know that our function is equal to a times 6 to the x. We also know that any one of these points makes the function true. So for instance, let's take an easy point to deal with. Remember, I'm talking about what happens when it's not easy to extend the table and we don't necessarily know these guys. This is another way of finding out the value of the starting point. So we know that when we put in 1 into our function as the x value, we get out 24. Now I have 24 equals a times 6 to the first, which is just 6, which means that a in this case, if I divide both sides by 6, must be 4. At that point, I could write that our function is 4 times 6 to the x. So that may help you with some of these tables. I don't know whether some of them are easier to just continue downward until you get to 0 once you know the multiplier, or whether some of them are going to be easier using this method in order to get to a. Either way, let me know if you have any more troubles. Thanks.